All right, welcome. We're going to do a distillation of Cherry Pepsi in this video, and I have an empty beaker. Okay, nothing is in it. There was a couple drops of water, but nothing's in it. I'm going to set it here at the very end of our collection vessel. I had some that I was running already, but I am going to put a little bit more Cherry Pepsi in there just to get us on the right path. Make sure we got enough in there. And just to prove, this is Cherry Pepsi, watch this. Drank it all up. So, Cherry Pepsi, how we do distillation. Distillation is based on boiling points and separating different mixtures based on boiling points. So we have a Bunsen burner here. I'm going to strike it, and we're gonna let this start to heat up and to boil. Now, if I had left that in there, all of the vapors that are going to start to come out as the water starts to boil out and all the extract, for example, the cherry extract starts to boil out and heat out, they would just escape out the top and that would be pointless. So I'm going to cap this, and as we put the cap in there, as this starts to heat, those vapors are going to rise. And as they rise, they're going to be forced into the top, and they could be forced down this chamber, but they would just continue to come out as gases because they're at a really high temperature. And so what we want to do is actually cool them down. So I have the sink hooked up, we got a hose coming down and through to one end of our distillation setup tube in our cooling chamber, and then we have another one going out. So you'll notice some motion in here once I start to turn this on. And so now we have water. You might actually hear the water, so I apologize for that. Now, if I can set it, maybe it won't drain as loud. I have an older sink, so I apologize. One of the things that distillation is used for, and you often maybe hear it is for example, in a distillery, making alcohol, whiskey, vodkas, gins, things like that, and making a higher concentration because they're removing all the impurities. If you were trapped on an island and maybe you had salt water and you had no way to survive, obviously you don't want to drink the salt water. If you were able to heat up the water and allow it to evaporate out or to boil out, it would just go into the air and you would have lost it. But if you devised a system that could collect that water and then pull it over to another system, you'd have pure water and all the salts would be left behind. Another place that you hear about distillation is with something like this. You can get lab grade, or you can even go to the grocery store and buy distilled water, and they often call it deionized water. In some cases they may use and have a different setup, and all of a sudden you are going to pull out all those impurities from the water. And so we want to make sure that things that we're looking for maybe are removed. So for example, if it's tap water, the tap water might have iron in it, tap water might have calcium in it and chlorine in it and maybe microscopic organisms. So we want to be able to take all those impurities out. If we think about the soda, if we look at the ingredients, the first ingredient, obviously carbonated water, but then we have high fructose corn syrup, then we have caramel color. So that's what the dark color's for. We're taking the dark color, and what's eventually going to happen in our distillation tube, as the vapors come up, once they come here, then they're going to be rapidly cooled by the cool water that's coming through this. This is actually a glass tube inside another tube. And so as it's surrounded by cold, the vapors that are going through that inner tube are going to be condensing, and we're going to start to see some drips come out at the very end. We're going to be able to collect in basically a more pure substance. And so we're going to end up with something that looks nothing like what we had. The next ingredient, sugar. So more sugar. In addition to the high fructose corn syrup, we have phosphoric acid, we have natural flavors, we have caffeine and citric acid. Now, if we really wanted to devise a distillation setup that was even more precise and more particular, we would put a setup in here that had a thermometer. The thermometer could go in and record the temperature of the liquid that's boiling, because each of the different components have different boiling points. So I mentioned the caramel in there. I mentioned the phosphoric acid. I mentioned, the carbonated water. We have all these different things, and there's obviously a very generic labeling, just says natural flavors. That's going to be the extract of that cherry. And so all of these have different boiling points. So if I can boil them off Some of them would actually boil faster than others. And if I really wanted to have a very precise setup to only pull off certain vapors or certain fluids, maybe certain impurities, then obviously I would have to set this up as a thermometer. This is more of a qualitative reaction, a qualitative demonstration, just showing the general concepts of what's happening when we actually go through distillation. And so at the very bottom, it's hard to see from the video. We'll come up closer in a minute, or I'll try to zoom in a little bit. But there is drips of water, or liquid I should say. I'm not really sure exactly what it is, but there are drips right here forming. Obviously, we're starting to see more bubbles even from a distance, so the whole system is boiling. We're starting to see vapors. It's getting a little darker. If you, maybe with my hand, obviously the whiteboard doesn't help, but maybe with my hand a little in the background, we can see some of those condensing droplets forming, but also combination continuing up. We're now starting to collect some drips over here. Again, I'm not sure if you can hopefully see it in the background of the video, but we're gonna let this run for a few minutes and I will zoom in on it. But that is really the process of distillation. Distillation is based on different boiling points. There are 4 other major types of filtration techniques that we talk about in chemistry class. Another one being filtering. That's based on typically different size particles. The larger particles would be blocked by some layer of material. It could be cloth, could be filter paper. Think about a coffee filter. The coffee grounds get stuck, but the liquid goes through. You may have a Brita filter at home. The water goes through, but the Brita filter is a charcoal filter that will pull and take out odors, will take out contaminants, take out metals from that water. So filtering is one. Distillation, obviously, we're doing right here. A big confusion between distilling and evaporating is that distillation is with boiling, that happens throughout the whole system reaching a certain temperature. Evaporation, though, is something that happens just at the surface of a liquid. Evaporation can happen at any temperature. You don't need to get to a boiling point. And so one of the key things with evaporation is based on molecular bonding and the force of attraction between molecules. So if you've spilled water on your table versus spilling rubbing alcohol on something versus possibly acetone or nail polish remover, if you look at a puddle or a little sample that's dropped of rubbing alcohol or nail polish remover, you'll actually see that start to evaporate and get smaller and smaller and smaller within a matter of seconds. The water will last a lot longer because water has a better intermolecular force of attraction. The acetone or the nail polish remover, the rubbing alcohol, their intermolecular forces are weaker, so those molecules can't hold together, therefore they go back into the gaseous phase and they evaporate. The 4th and the 5th one are not talked about as much, but are also important, and one of them is called centrifugation or a centrifuge, where materials will spin around and the larger, heavier, more dense objects will settle out, and then the less dense objects will be on the top. So if you ever get blood drawn or blood taken out, you will actually have the doctor or the nurse take the sample of the blood, and then they may put it into a machine that spins it around. They can either sample the plasma, they can sample the heavier, more dense platelets and red blood cells and white blood cells, depending on what they're looking for. And then finally, the last one, it's hard to see, but that paper way up there in the corner has different colors that are separating. The process known as paper chromatography is the 5th example of ways that we can physically separate mixtures. And chromatography in the biological aspect, similar, you may have learned something like DNA gel electrophoresis, based on charges, different molecules going through different mediums. The larger particles will get stuck back, the smaller molecules will move forward. With paper chromatography, it's based on polarities and symmetries. The things that are more similar to water will transfer and travel more through the water and go farther up the paper and separate, where the ones that are different from water are going to be stuck behind. So if I used an ink pen, that ink would have stayed at the bottom, but because I used food coloring is water soluble, had the ability to transfer up. So this has been working for a while. I'm going to actually turn this off. We're going to kill the gas. It's still boiling, but maybe you saw some of the drips, but I'm going to bring this over and we'll catch the last drip here. And what I want to show you now is we now have that product. That product is going to be it has the odor of cherry. And so it's very dilute. I'm not going to drink it because we had dirty lab equipment, we had dirty beaker, so on and so forth. So we have this nice clear liquid that actually came out of that dark stuff. So that is the process of distillation. Thanks for watching.